All right, so here we are, class number 5 for packet 6, 19th of April. Let's see what's happening here. No, before we do that, okay, let's take a look and see. That's what happened last week. Not a lot going on there. Let's go to this week. So this week, I'll meet one of you tomorrow. Hopefully we can pull that off. Tomorrow evening, you guys, I'll have it on. I'll put it on the Facebook group. I'll put it on the Canvas, and I'll put PDFs of it up so you can print it off, get a nice printout of it. No, well, yeah, for you all, you'll need PDFs. I mean, I have paper copies, and I'll put some of those on my front porch. But it'll be the first set of practice problems for the test next week. Not this Thursday, but a week from Thursday, test 6A. Wednesday will be an important day for us because I'm going to put the test, the test 5B is graded. I'm going to put those grades up tonight. Now, some of you are seeing that your packet is being put up there and your scores have shot up. Right, kids 110% in class because that packet, had a lot of bonus built in. Well, the test, when it goes up tonight, will bring it back down a little bit for most people. Some people tests actually help their grade, but most people it does. So that's tonight. That'll go up, and then I'll continue to put in packets into the grades tonight, tomorrow night, and it should all be done. They should all be in by tomorrow night. Everything should be updated by. I like to have all my grades updated by Tuesday night. So if there's anything you need to turn in, like if you got to turn in packet 5, I would take scan everything, okay, into the same document, and then I'll scan all 12 plus the take home test, scan everything into one document, and then email me that. Okay. So anyway, Wednesday's flex day. So Wednesday we will go over that test here during 1:10 to 2 o'clock. We'll go over a video key for that test and talking about kind of how you did in blue and black points. All right. Which ones are blue, which ones are black. So all that stuff comes up Wednesday. So then you'll kind of refer to that Wednesday, Thursday, and then you'll turn it in Friday. Everyone turns it in Friday. You can submit it through Canvas. You can take it to my porch. It's up to you. But you can submit it through Canvas. Now, the thing about you all is I have your tests. You don't have your tests. So we're going to figure that out, how we're going to do that. I mean, I can put your tests in the folder on the front porch. You can come get it. But that's going to be kind of tough with you guys. We'll figure something out. All right. So that is due Friday. Okay. So now I have a special presentation. Let's see if this will work. Let's see if I can pull it off. Okay. Here we go. Hold it. Here it is. So that is the opening to May. May is upon us. There's been a May sighting. Take a look here. The next calendar, looking ahead, and there it is, hiding. Saturday, not this Saturday, but a week from this Saturday, May 1st. And so the month of May is a glorious month. Very busy, very busy. That's going to be the prom too, I think, May 1st. Now, so a week from today, actually a week from yesterday, I'll have the second set of practice problems for test 5A, and then I'll hand them out in class, but you all will have access to them Sunday night, the 25th of April. Flex day again, it doesn't matter to you. Flex day doesn't really affect you guys. We still do 110 we do a little less. We don't go as Usually on flex day, ours only lasts about 30 minutes. So. And then the last A type test, 4A, 5A, 6A, the last A type test is going to be a week from Thursday. Now, for you all, you have special instructions. You all will get it on Friday. Class will be Thursday. For you all, it'll be Friday. I'll email it to you at 2 o'clock Friday next week, not this week. And then you'll have till Saturday to turn it in by 6 p.m. to submit it. I think submit it. We'll get those details later. Anyway, that's we got a ways to go for that. Now, then the couple weeks from now, May 3rd. Now I put in here all the AP tests. So like if you're AP Physics, which obviously you aren't, but you would have a test in, I can't believe the AP Physics test is in 2 weeks. That's crazy. AP US Governments. Okay, if you're in AP Calc, now some of you are in AP Calc, that's Tuesday, the 4th of May. That's coming up. That's a little over 2 weeks away. English Lit, some of you are in that. We got you APUSH, some of you are in APUSH. That's coming up the 6th of May, and et cetera, et cetera. So we'll have plenty of warning. Chemistry, if you're in AP Chemistry, that's going to be the 7th. So the AP tests are upon us. We still got 2 weeks of relaxation, sort of, and then the AP problems. So what else we got? Oh, this doesn't really affect you, I guess. I have tons of books that I'm going to get rid of. So in class, I'm laying out books every day for students to take. They're on physics, they're on chemistry. They're books I've had ever since I was in college. But I was going to wait till next year when I retire, but now they're making me clean out my prep room. And so I'm not going to get all the books out and put them all back. So I'm just going to go and start cleaning out now. So I have literally hundreds and hundreds and hundreds of books that I love, but I just can't. I mean, you can't take the books with you. So, yeah. So, I don't know if that affects you at all, but if you're into physics books, you can come by my room and I'll show you a few. I'll give you a few, or chemistry, or whatever, earth science, I got all that stuff. Now, Dr. Saparov has sent me that, so he's wanting if any of you. I know a few of you have mentioned that you're interested in that. I don't know about Sophia. I mean, Ellie is, Io is, Rose is. So of you all, those are the ones I think that has talked to me about it. And that is, you need to contact Dr. Saparov. He said, go ahead and have them email him. I've sent him a list of students that doesn't do much for him. He wants to hear from you. So you want to kind of sell yourself on that email. This is something you probably need to do. If you want to go to OU or OSU or, OCCC or something when you graduate, then it doesn't really matter. I mean, you're probably your grades are probably okay and you're going to get into those schools. But if you're trying to go compete like Caltech or Stanford or MIT or some of these other schools, even UT, that are pretty picky about who they take, every one of those students that sign up for, they're all 4-point. They all have the tough scores. They all take an AP classes. Everybody's in the same boat. You got to distinguish yourself, and it's these kind of opportunities that allow you to distinguish yourself. If you're from Durant, you can't really do this kind of stuff. So you ought to take advantage of living in Norman. One of the advantages, go to OU. So try it anyway. If you don't get in, well, at least you put your name out there. There's a lot of people wanting to do it. So, but go ahead and try it. You get $200, plus you get to work in a lab that's with professors. This I came across last week. I was looking through. I look at old student notes all the time. Like I'll take pictures of your notes. Sometimes they have really good notes, and so I'll take pictures of. Sometimes you don't know I'm taking pictures of it, but I'll take pictures of some. If you have a good way to say something, like very colorful, you have very, very creative people, and so I've taken notes of Miranda's stuff before, of Sophia's stuff, Rose's stuff. I have taken some notes, some pictures of those, and I'll take others too as we go. Well, Here's a picture I took, and I think this was a guy. It just doesn't have the handwriting of a girl. And I don't mean to be sexist, but I've been looking at handwriting for 35 years, and that seemed like a guy. But here's this first one, it says more. So the guy's been thinking, and he's this. What I love reading this because this is his thoughts, not my thoughts. He says he's writing some stuff here. He goes, okay, I think I have everything I need. This wasn't an assignment. This was him just pondering physics. He said, if delta P equals 0, then no force exists, or no summation of force exists. And so he said, okay, well, in that case, I can do this. And then I got it here. Wait, I can undo that. So I'm not sure what he was even trying to accomplish. But the fact is, I kick at myself that I did not write down the name of this person. Like I said, it's about 10 years old. And I bet I don't know what this guy's doing right now. But my guess is it's something involving hopefully engineering or physics, because the guy's a thinker. And so I want to see more of that from you. You can just use your notes just to write out thoughts, and maybe you're just writing your philosophy. Maybe you're writing a poem, but you're writing out thoughts on what you're experiencing in the world. Maybe it's in my classroom, maybe it's some other way. But that's what I like to see in notes. Finally, Sarah Embry put this on our Facebook group. And yeah, it's interesting, the idea that there may be a fifth force could change physics as we know it and all that kind of stuff. But what I thought was cool, and I acknowledge that, but what I thought was cool was TikTok, which I'm starting to get into now because I want to advertise, I want to put stuff on that'll help us with our nonprofit that we're working on through TikTok. And we're going to add some TikTok. That's the idea anyway. So I'm trying to familiarize myself with TikTok. So this is a TikTok. I think they have to be 1 minute, right? They can only be 1 minute. And so this is a 1 minute quick video. I'm not sure who this person is, but she's talking about this new thing they found with the muons and stuff in physics. So Sarah did that, and I gave her 5 Facebook points for that. And so I'm going to make that offer to anybody. If you can find good TikToks that have to do with physics or some kind of phenomenon that we're studying, or even that we're not studying, it could be astronomy or something. And you'll put those TikToks in the Facebook group. I want to make another guide, another unit, and it's just going to be full of TikTok videos. I mean, Instagram as well is fine. TikTok's kind of the latest trend, but so things that I kind of like them as are 1 minute little clips, little thoughts. And so if you do that, I will reward you with 5 Facebook points, and you can get up to 100 Facebook points doing this. That's 20. If you give me 20, 5 each, and that's the your maximum, but that's still 100. And these are all bonus points. So you could get up if you choose to do this. I don't even know if there are that many physics TikToks out there. But they got to be quality. Don't just go round up a bunch of crap. Okay. I said up to 5. If it's crap, it's 1. All right. So the higher the quality, the more up to 5 Facebook points. Okay. That's it for announcements. Any questions? Oh, let me call up I know I can see you. You can't see me though. For some reason. I don't like it when that happens because I'm putting my business in the line here. If I'm trying to Zoom with my class and they can't see me, that's not going to be good. Okay, so did our joke Monday today. Let's keep going. That was a 1995 throwback there. All right, so I want to share a different screen, and let's watch, because the big news of the day, of course, at 2:30 this morning, Oklahoma time, we had liftoff on Mars. So let me share that screen. Hold on. Do I have the right screen? Hold on. Let me get the right screen called up. Okay, this one. Okay, so I want to show you this. It's about a 2.5 minute video. We'll pause it and talk. We did this in class. I'm trying to recreate the classroom experience for you. So now let me share that one. Okay, sharing that one. Yeah. Oh, sorry. Try it again. Am I sharing the right one? Hold on. Hold on. Where the heck? Where'd you go? Oh, here it is. Here it is. Okay. So I'm going to share it again. Try and share it again. We'll obviously have to edit all this out. Now, share. Okay. Now we got it. So this is 2:30 this morning. This is at JPL. Dane is not on this team. Dane's on the Curiosity team. So he was off and he's probably in bed asleep. But here it is.
Celebration this morning at JPL Mission Control. Stunning images just coming in as NASA yet again pulls off the unbelievable, flying a 4-pound autonomous chopper, a drone really, on another planet.
Now, 4 pounds is about the size of a 2-liter bottle of Coke. But notice this, the only chance we get to get a close up. See, these wings are a little bit different than our propeller wings on a helicopter. They're a little wider. You want to maximize your wing area, and we'll show you that in the formula here in a minute. So very light, got a camera on there. I don't know if there's any other sensors on there. Maybe there's an air pressure sensor, I don't know, but there's a camera on board.
The rover Perseverance captured the entire flight, all 40 seconds of it, as it lifted off around 3:30 a.m. Eastern Time, climbing to an altitude of about 10 feet before settling.
Now, one thing I noticed about this animation, this is still that we're going to get some real footage if we don't already have it from Perseverance. Did film the whole thing, but here's animation that they brought in some sound. It doesn't. Thing is, it's going to have a little bit of sound, but it won't sound like a helicopter on Earth, right? Because you got 1% the atmosphere. So you have to have atmosphere. You have to have a medium to carry a sound wave. You have to have molecules, air molecules, and there just aren't. There are some, but not many on Mars. All right.
Back down again on the Martian surface. If all goes as planned, it's just the first of many flights to come.
We really want to push our vehicle to the limit. It's not every day that you get to test a rotorcraft and do an experiment on Mars. So after the third flight this morning, we are going to be very adventurous.
NASA calls it a Wright brothers moment on Mars, and it's carrying a tiny piece of fabric from the original Wright brothers plane. After a 292 million mile journey, this tiny chopper had to delicately detach itself from the belly of the rover to stand on all 4 legs, then survive freezing nights up to negative 130 degrees Fahrenheit, heating itself with solar panels and internal heaters. And Ingenuity's onboard computer packs the power of a cell phone, but 150 times stronger than anything launched to another planet. Since it takes 12 minutes to communicate with Earth, Ingenuity must fly itself, making 500 calculations every second. The biggest challenge, the Martian atmosphere is only 1% the density of Earth's. So engineers designed 4 rotors that spin 5 times faster than a helicopter on Earth. The ultimate goal, use aircraft like Ingenuity to explore canyons, ice caps, and remote terrain before humans ever land on Mars. Engineer Mimi Ong heads up the Ingenuity team.
This must have been how the Wright brothers, must have felt. And I feel so humble to compare our team to the Wright brothers, but they really are, our role model.
This morning, one small drone flight, but a giant leap for aviation on another planet.
Okay. So let's go back to the other screen. And let's share this screen again. All right, so I want to do a quick free body diagram, and then we'll talk about the equation involved. So that's kind of a blurry picture of the Ingenuity. So do a little drawing there in your cheat sheet notes. remember you get to use your notes on 6B. But let's do the forces. Let's assume just after takeoff. So let's do a FBD. So this FBD will be just after, meaning like a millisecond after takeoff, after it left the Mars surface. What would be the forces on that helicopter? So take a minute and think about it. And in the chat, list a force. Give me one force per person, one force that would be on that helicopter. And then we'll see if we agree with you. Okay, lift. And the force of lift. Now, Io said thrust, and it's not thrust, and there's a reason why. We're not expelling anything. We're not expelling, it's more lift. But thrust would be a pretty good guess, but it's not. Mg and weight are the same thing. So, okay, so here we go. So I agree with pretty much what you guys are saying. There is an mg. Now, let's get numbers to this. So there is a mg down, and that mg, the mass of this, they said it's about 4 pounds. Let's say approximately 2 kilograms. And then the G on Mars is 3.7 meters per second squared, as opposed to 9.81 on Earth. So we're looking at about 7.4, right? So it's about 7.4 newtons on Mars. So in order to just lift off the ground, you have to have a little bit more than that, 7.5 being enough. We'll go ahead and say 8. So the force of lift caused by those blades must be 8 newtons. Not thrust, because we're not expelling anything. No drag. Why isn't there drag up there?
No air.
No air. Well, there's 1% air. So thing is, it's one of those things you'd say negligible drag. I can't say it's not there. I mean, Miranda technically is correct. Plus, it wasn't going very fast. But the formulas are still the same. 1F d rho A v squared. So the force of lift, the formula for that is 1/2 CD rho A v squared. So it's very similar to drag. This is the A drag coefficient. This is very small. This is rho. This is 1% the Earth, so 0.01 times the Earth's. And Earth is 1.2 kilograms per cubic meter. So up there, let's just erase this. Up there, we're talking 0.012 kilograms per cubic meter, right? 1.2, yeah, 100 times less. And then the A, so the only two things you have to give you a break up there is the wing area. That's the wing area. And so you see there's 4 of them, and they're pretty wide. And then the main thing, though, is velocity. And it said it's moving at 5 times the normal helicopter speed. So 5 squared, that's 25 times. And this is probably something like, say, 3 times the normal area. So you get those, you're trying to counteract. The thing is, though, it doesn't have to counteract as much because the FL doesn't need to be as big. It just needs to get above 7.4 newtons. So that's the thing that physics allows you to do, is to start diagnosing and actually put numbers to what you're seeing out there. That's kind of cool. Okay. We did this on Friday. We looked over the free body diagrams of a car. We talked about how the drag's going up exponentially, how the lift's going up exponentially. And that leads us to the first two, slide 13 and 14 of the equation sheets. We're going to get a lot of equation sheets over the next couple of weeks. So let's see what's on here. Now these you will get, you have access to these on tests. It's legal to look at all the previous equation sheets. So when you're sitting there at home taking test 6A, it's not illegal to refer to the Facebook group, or perhaps you printed these out and get these out. So there's the magic triangles. There's the Newton's second law. There's a handy that's a handy guide to all the forces. All these forces are the ones we're going to deal with the rest of the year. And then this rule of thumb here: if when a car starts going at 30 miles an hour, we start to give a baby airlift. A baby drag. A baby drag at 30 miles an hour, 35, 40, 45, it starts to grow. And then at 50, the air drag is the same as about the same as static friction. Now this is for a generic car. It depends on the shape of the car, the aerodynamics of the car. And then at 60 miles an hour, we're saying we're starting to get a baby force of lift. Still pretty negligible, but at 70, 80, 90 miles an hour, it starts to become substantial. And so I went ahead for the first time ever, included some of those from the stuff we did on Friday, the free body diagrams of a car speeding up from 0 to 130, how all the forces are changing as you go. Okay, that's one worksheet, one equation sheet. The next one is air drag. We've talked about that equation a number of times this year and detailing it all out. There's static friction, kinetic friction. We'll spend a whole day on those two later. Here's the force of lift. We just got finished talking about that. And then down below, there's Brownian motion, the motion of air particle in the room, the laminar flow versus turbulent flow. And this one's pretty good for a wing. You probably need to know all this. We'll get to thrust more tomorrow, but lift is always perpendicular to the direction of motion. There has to be an attack angle, or the wing will not lift. You won't get your plane off the ground. As you're flying along, you have to maintain that, and you need that attack angle. Drag is always opposite the direction of motion. The weight, there's your mg down. So those are the main things for a airfoil. And finally, we talk about, I don't know if you guys ever play pickleball. Pickleball is like the latest thing, right? So pickleball is big down in Austin. So when we go down there, we have a pickleball court we go to. Well, the pickleball doesn't have any fuzz. It's not like a tennis ball. It's kind of like a racquetball, right? So the reason is you want there to be a lot of drag on a pickleball. You want there to be a lot of drag on a racquetball because those courts are small. You would not want that for a tennis ball. It wouldn't go very far. So it's all about separation point. And in fact, we'll watch a video tomorrow on golf ball and its dimples and it's all what's going on over the surface. All these little eddy currents. As that air comes over the surface, it gets stuck. Sometimes not really stuck, but stuck in little eddy currents along this. And so you want to fuzz it up. You want to make it so it doesn't cling to